Welcome to Eureka Math, Module 4, Lesson 13. Today's I can statement is I can analyze, which means to study and pay attention to details, and classify, which means to sort, triangles into different categories based on their side lengths and their angle measurements. Now, what I have prepared for me today to show you in this lesson, I need for you to go ahead and get ready. So you're going to be looking in your Learn book on pages 95, 97, and 99, and I'd like you to cut out these 6 triangles. So if you don't have them cut out already, which I suspect you probably don't because I'm giving you the directions now, you'll need to go and pull them out of your book. They are on pages that look like this. This is the teacher manual, but they look like this. So go ahead and cut them out. And then when you have them cut out and arranged sort of like I do, I want you to come back. I also want you to have close by you your Learn book, and I'd like for you to open it to page 101. This is going to be a chart where we do some of our work today classifying these different triangles. So if you don't have this ready, push pause, and when you come back with your 6 triangles cut out, you'll need a pencil and you'll need your Learn book for this activity. So come back to me when you are ready for this. All right, well, I'm going to assume that you are ready, that you've got everything that you need. So let's get started. So what we're going to do today is we're going to begin by going back over something we learned yesterday, which is symmetry. And symmetry is where we find out if a shape or an object has a line that can be drawn down the middle of it, and each side can then be a mirror image. So what we're going to do is we're going to take each of these triangles and we're going to identify the lines of symmetry in these triangles. And you might be thinking, well, what does this have to do with our lesson today, Mrs. Isley? But it actually has a lot to do with our lesson. So let's take triangle A and let's see if we can find any lines of symmetry in triangle A. Well, I can do that. I've got one going from this point, and I'm just going to go ahead and just dash those lines of symmetry. You can do that with me. But triangle A has a line of symmetry here. Is that all? Well, hopefully by now you've recognized we can turn these shapes and we can see that no, this shape actually has another line of symmetry. Each one of these points of the triangles or vertices, I'm able to fold and go down between one vertice straight down to the middle of the opposite side. And if I turn it, I can see that I can do that again. And so this triangle is going to have 3 lines of symmetry. And that's going to become very important in a few minutes. Notice that when I folded each of these triangles, or when I folded this triangle each way, I noticed something about the sides. And what I noticed was that the sides of this particular triangle are all exactly the same. This side, and this side are all equal. Now, if I were to pull out my ruler, and if you have a ruler, I'd love for you to do this with me, but I realize that some of us don't. But if you pull out your ruler, you'll also recognize that this triangle measures the same on all 3 sides. But we're going to use, just simply put, the fact that it's got 3 lines of symmetry to recognize that all 3 of these sides are equal. All right, let's move on. And let's look at triangle B. Does it have a line of symmetry? Well, let's see. All right, I'm going to fold it. You can fold it with me. And I've got a line of symmetry vertically going up and down. So there's one line of symmetry. Any other lines of symmetry? Well, by now you probably know there's no other lines of symmetry in this shape. So what this is telling me is that this particular triangle has 2 sides that are equal and one that is not. So it's a little bit different from triangle A. Another important fact. Let's check triangle C. Okay. Nope, not a line of symmetry. This one has no lines of symmetry. Triangle C, none. I'm going to make a note of that. This one has 1. This one has 3. Okay, let's keep going. Let's check triangle D. No, I can't fold it over that way. These two lines look like they might. Nope. Triangle D, also no lines of symmetry. And so what that's telling me about both of these triangles is that they don't have any side lengths that are the same. Because when I folded triangles A and B, and I got at least one line of symmetry, I was able to see the sides that were perfectly matched. They were exactly the same length. All right, let's move on to triangle F. Now on this one, I'm guessing I see a line of symmetry right here. Oh yeah, look at that. Perfect match on both sides. In fact, it makes another little triangle. That's cool. Actually, all of them do. Let me draw that line of symmetry right down the middle. And that's the only line of symmetry that this triangle has, which lets me know that this side and this side are the same. This is going to become very important in a few minutes. All right, so this one has one line of symmetry. And then last, triangle E kind of just looks like a bigger version of triangle F. I did those backwards, but no biggie. All right, check it out. I've got another triangle with another vertical line of symmetry. Of course, I could have turned it that way. It would have had a horizontal line of symmetry. Doesn't really matter as long as I can see that line of symmetry, and no other line of symmetry in this triangle. So it's letting me know that these two sides are equal. This is going to be really important when we classify triangles. All right, so you guys know that even in kindergarten, preschool, that you did sorting. Well, what we're going to do today is we're going to analyze or study the different attributes of these triangles. We're going to study the side lengths and we're going to study the angles, and we're going to sort them into some different categories. The first category, the first type of triangle that we are going to identify is one called an equilateral triangle. And in an equilateral triangle, I kind of see the word equal, even though it's not spelled correctly. Do you see that? Equilateral. All sides are equal. So when we are classifying triangles by side length, and there's two ways to classify triangles. We'll talk about the second way in a few minutes. But the first way to classify triangles is by the length of their sides. An equilateral triangle is one where all sides are equal. Well, there's another type of triangle, and you guys might have already noticed that when I was sorting, I didn't have too many equilateral triangles, but I did have a couple of triangles where two sides were equal. And that's a different type of triangle. And that type of triangle is called an isosceles. Try to say that with me fast 3 times. Isosceles, isosceles, isosceles. It's kind of a cool word. It's hard to spell. But when I say that word and I don't look at it, isosceles, do you know what I think about? I think about eyes. Now, how many eyes do you have? 2. Isosceles, I think about eyes, and I think, hey, if we have 2 eyes, then an isosceles triangle has 2 sides that are equal. So we've got equilateral triangles where all sides are equal. We've got isosceles triangle where 2 sides are equal. And then last, and we did notice that we had some other triangles where no sides were equal. Well, there's a category for those triangles too. And those triangles are called scalene triangles. And that's just kind of a weird word. It makes me think of scales. Scalene. Now, scales aren't bad. They're not weird. We got people here who are listening who love They're reptiles, and that's you, Adrian, I know, as well as some other folks. So scales aren't bad, but it just kind of is a funny word, scalene. So that helps me think it's kind of a funny triangle. It has no sides equal. Well, now let's pick up our stack of triangles and let's try to sort these triangles based on their side lengths. I'm gonna try to give myself as much room as I have. Now, if you're at home, which you are, I know, unless you're at grandma's house or something like that, it might even help for you to grab a sticky note and make yourself some labels, just like I did. Or if you have index cards and you want to make yourself some labels, just like I did, you can push pause, you can go make these labels, and you can come back. That's totally optional. Now that I've got my labels and I've got my triangles, I'm going to see if I can sort them. So the first one I'm looking for are equilateral triangles. All sides are equal. Well, as I look through my triangles, I know the only one that really fit that description was triangle A. All sides were equal. Now the cool thing about triangle A that we noticed is that triangle A has all these lines of symmetry. It has 3 lines of symmetry, and it's got 3 sides, and all of those sides are equal. Well, guess what? All 3 of the angles are also equal too, because they would match up perfectly if I put them together like a puzzle. I could see this angle and this angle and this angle are all the same, and that's going to also become important later on. But this triangle is called an equilateral triangle. Now, I mentioned this in our symmetry video yesterday, and I said that anytime you have a shape that has all of their sides equal, that it's called a regular shape. So this would be a regular triangle because all 3 are the same, and it's got 3 lines of symmetry and all 3 sides are equal. So equilateral triangle. Now we're going to go on a hunt for our isosceles triangles. So look through your stack of triangles, and I want you to see if you can find all the triangles that have 2 sides that are equal, like you have 2 pairs of eyes. I'm going to lay them down right here. That might be a little challenging because some of these are kind of big, but triangle B has 2 sides that are equal. Triangle F has 2 sides that are equal, and it's okay if I turn it this way. It's still an isosceles triangle. And triangle E was also an isosceles triangle. Because the thing that's important to remember about all of these is that they have 2 equal sides. Now I'm going to stop right here because I forgot to do something on my equilateral triangle. And what I want you to do is I want you to grab a pencil. If you want to grab colored pencils or pens, you can. But I'm going to make some little marks on these triangles showing the sides are equal. So on my equilateral triangle, all 3 sides are the same. So I put a little mark, just like that. And I'm marking that all 3 sides are the same. I'm putting a little 1 because all 3 of these sides are the same. Over here on my isosceles triangle, I'm going to put a matching mark on the 2 sides that are the same. I'm going to do that on all 3 of them. All right, you match you, and you match you, and you match you. And just like in geometry, when we put that little box in a corner to show, or in an angle to show that it's a right angle, this is just another way of showing congruency or equalness. You are equal to you. This side is equal or congruent to this side. But what about that other side that isn't equal? Well, what I'm going to do is I'm going to take I'm going to use a different colored pencil, but I'm going to draw 2 dashes down here. And I'm going to show, hey, this is a whole new side. That's why it has 2 dashes. It doesn't have anybody that matches it, but these 2 are the same because they each have 1 dash, and this one has 2, so it's kind of the oddball. Same with this isosceles triangle and this one. All right, so we've got our equilateral triangle we have our isosceles triangles where we have two sides that are equal. And then our last category is our scalene triangle. And this is one where no sides are equal. And funny enough, our scalene triangles are the sides that didn't have any lines of symmetry. And you might be wondering, well, why is that? Well, these two have two sides that are equal, which makes them isosceles. These three, rather, have two sides that are equal that make them isosceles. And that one line of symmetry can show us how these two sides are equal. And that would be the same for both triangle B and triangle E. But when I come over here to my scalene triangle C and my scalene triangle D, where I have no sides that are equal, well, there's no line of symmetry in these triangles either, and that's because nothing matches up. They're all different. So the way that I'm going to mark these is I'm going to mark this side length with 1 dash. Just pick whichever one you want. Then I'm going to mark another side with 2 dashes, and that's showing that these are different from each other. And then in this particular triangle, there's a third side that's also different, so I'm going to mark it with 3 dashes. Let me show you that up close a little bit more. So it's got 3 different markings because the side lengths are all 3 different. All right, so now you have seen how we sort and classify triangles by their sides. But that's not the only way that we classify triangles, because triangles, as we know, are shapes that have 3 sides, but they also have 3 angles. So we can also classify triangles by their angles. So I'm going to stack my triangles back up, and this time I'm going to get out another set of cards. Equilateral, isosceles, and scalene are ways that I sort my triangles by sides. But now I'm going to think about how to sort them by angles. Now this is actually easier because you don't have to remember any new words here. You'll see these words that I put down are very familiar. So I'm going to put down acute, which you guys know. An acute angle is an angle that is smaller or less than 90 degrees. And this is why we learned about angles before we started to do this. We also know about obtuse triangles. Obtuse angles. Whoops, I'm getting ahead of myself. And obtuse angles are angles that are greater than 90 degrees. And then, of course, we have right angles. And right angles are angles that are exactly 90 degrees. So I'm going to pull back out my little right angle tool. No worries if you have lost your right angle measuring tool, because you can make another one. Remember when we took that time the other day to create our right angle measuring tool? If you've lost your right angle measuring tool, you need to just grab a piece of paper. You're going to fold it once hamburger style. You're going to fold it once again hamburger style. And when you do that, you are creating in any of the corners a right angle that measures 90 degrees. All right, you're going to need a right angle measuring tool for you to continue on with this little process that we're doing today. So if you need to go make one, go make one. If not, grab your trusty right angle measuring tool, and let's see if we can sort these triangles by their angles. So an acute triangle is defined as a triangle that has all angles that are acute. So all angles are going to be less than 90 degrees. Obtuse triangles are triangles that have one angle that's obtuse or over 90 degrees. A right triangle is one that has one right angle. Now you might be thinking, Mrs. Isley, are there any triangles that have 2 obtuse angles? And the answer is no. And I'll have to explain that to you in a different session. But If you watch the Math Antics video that I've linked on today's page, then you will probably be able to see in that video, in fact, I know you will, why you can only have one obtuse angle in a triangle. If not, I'll explain that later. And a right triangle is defined as one triangle that has one right angle. And again, you might be thinking, well, Mrs. Isley, can a triangle have more than one right angle? No, it cannot. A triangle can only have more than one acute angle. It can have one obtuse angle or one right angle. All right, let's pick up our stack of triangles and our right angle measuring tool, and we're going to see if we can figure out which ones are acute, which ones have all acute angles. So I'm going to grab my measuring tool, and I'm going to put the corner, the vertex of my right angle measuring tool right in line with the vertex of each of my triangles. All right, I can see right here that this is no right triangle. This is actually an obtuse triangle. Triangle F is obtuse. It's got one obtuse. That's all I have to see about it in order to classify it as an obtuse triangle. As long as it has one obtuse angle, it's good to go. Give you a hint, the other two angles are acute. All right, let's see. I'm going to take triangle A. I'm going to look at triangle A. In fact, it's kind of cool because I can put it on top of my measuring tool and I can see that's an acute angle. That's an acute angle. That's an acute angle. All right. Remember, an acute triangle has all angles acute. So triangle A is an acute triangle. And we called this triangle an equilateral triangle last time. Now we're calling it an acute triangle. And in just a minute, we're going to put all this together. All right, let's take a look at triangle B. Let's measure triangle B. All right, acute, acute, acute. All right, triangle B, you're acute. Let's take triangle E. I'm just grabbing them. I don't have them in any specific order down there. All right, check your angles here. Definitely have acute. Oh, look at this. Look at this. Perfect right angle. So what is it going to be? It's going to be a right triangle because it has one right angle. So triangle E, I'm going to call a right triangle. I've got two more that I'm going to check. I just grabbed triangle C. I'm going to check triangle C. Acute. Acute. Ooh. Ooh, wait a minute. Oh, this one's way bigger than 90. All right, what do we call an angle that is greater than 90 degrees? We call that an obtuse angle. So triangle C is another obtuse triangle. And I've got one more triangle that I'm going to look at, and this is triangle D. I'm going to check all those angles. Ooh, look at this. Got another right angle. Immediately categorizes it as a right triangle. All right, so I have three acute triangles, three obtuse triangles, and I'm sorry, I don't know what I'm thinking here. Two acute triangles, two obtuse triangles, and two right triangles. And so what I think I will do now is I'm going to make that little square in the right angle corner of my two right triangles, showing me that these are right. I also know that this angle in triangle F is my big obtuse angle. I think I'm going to go ahead and write that in. Same over here. I'll just put an O for obtuse. And that's just going to help me remember in a few minutes what I'm going to call these. And then last, my acute angles. I think I'm just going to draw the arc in here. And I'm just going to label it A, in all three angles because all three angles have to be acute to make an acute triangle. All right, so what we have done is we have classified our triangles by sides and by angles. Now we're going to do a little bit of work in our book. And I told you earlier what we were going to do is we were going to take page 101. We're going to take that out. And I want you to do that too. I want you to have your triangles just here on the side. And we are going to fill in this chart about the attributes. Now, we're not in class. If we were in class, we would have our protractors out. We would be measuring the side lengths and the angles. And that would be, we'd be doing this really specifically, but we're not going to do that today because we just can't. We don't have protractors. But what we can do is we can write down some of the things, looking for a pencil here, we can write down some of the things that we noticed about these triangles. So let's take a look at triangle A, and you need to have your chart from page 101. Triangle A, I'm going to write down what I noticed about triangle A. Let's look back. It has three sides that are equal. So I'm going to write that down. 3 sides equal. And then what type of angles did it have? Well, it had 3 acute angles. So I'm going to write that down. 3 acute angles. And then I'm going to classify it. And when I classify it, that means I'm going to give it a first name and I'm going to give it a middle name. The first name is going to be based on its side length. Let me just check. Yep, that's how Eureka Math is going to continue doing it. And its second name is going to be based on its angle. Well, I remember that a triangle that has all 3 sides equal is called an equilateral. And I know that a triangle that has 3 acute angles is called an acute triangle. So triangle A's official fancy name is it's an equilateral acute triangle. That's the fancy name of triangle A. Equilateral acute. First and middle name. Let's take a look at triangle B. It's a good thing we drew all over it because that's going to help us. Triangle B, let's look at the sides first, and it has 2 equal sides. And what about its angles? Well, let's take a look. That's why we wrote the little A in all of these angles. It has 3 acute angles. So let's give triangle B its fancy name. What's the name of a triangle that has 2 equal sides? Isosceles. Triangle B is called isosceles, and since it has 3 acute angles, acute. So triangle B, your official name as a triangle is isosceles acute. All right, let's take a look at triangle C. I think you're probably getting the hang of this by now. First, we're going to look at the sides. 3 different marks. I have no equal sides. Now, let's look at my angles. Remember how I drew this in and I recognized immediately that there was an obtuse angle? Well, it has 1 obtuse angle, and all an obtuse triangle needs is just 1 obtuse angle to be classified as an obtuse triangle. So I know that by the sides, there are no equal sides. So this one is called scalene, and it has 1 obtuse angle. So this triangle is named scalene obtuse. Hello, scalene obtuse. It's not a very pretty name, but oh well. All right, triangle D. Let's take triangle D. Ooh, I can look at this one immediately and I can see by the sides, 3 different sides. So no equal sides. And this one has a right angle. 1 right angle. And 1 right angle is all it takes to make you, triangle D, a right triangle. Well, triangle D had no equal sides, so it's also called scalene. But since it has 1 right angle, it's going to be a scalene right triangle. So hello, Mr. Scalene Right. All right, head over with your friends. All righty, triangle E. Triangle E. Let's take a look at those sides. This is why it's so important to make these marks. Yep. 2 equal sides, isosceles. And 1 right angle. So, you, my friend, are an isosceles. Right triangle. Remember, first name goes for the side, second name goes for the angle. So I've got my isosceles right triangle. Off you go, isosceles right. And last but not least, we have triangle F. Oh, let's look at triangle F. 2 equal sides. And what kind of angle? It is so good that I've already written this stuff down, you guys. You have to do this for all your triangles. This is showing your work on triangles. We're not guessing. All right, 2 equal sides and 1 obtuse angle. All right, this is also an isosceles, but this one is isosceles obtuse. That's a weird name too. All right, Mr. F, you are isosceles obtuse. So the important thing to remember today is that triangles get 2 names, a first name and a middle name, just like you. The first name is their side length. The second name or the middle name has to do with what kind of angle they have. Now, I have made for you or printed for you or attached for you, your parents will have to print it, a chart that looks like this. It's actually a picture of this chart and it is in Canvas. And so while you are doing your work today, I would really like for you to have something like this in front of you because it's hard to remember all this stuff when you've just learned it. In our classroom, we would have this hanging up. It's called an anchor chart and you really are going to need it. So if you were not able to print it out, I'd like you to have this, a picture of this open, or you can copy it in your math journal, but you're going to need something to help you remember all these crazy new names that we've learned. All right, remember we classify triangles first by their side length. They're either equilateral, isosceles, or scalene. And second, we classify them by their angle. Acute, if they have all acute angles, obtuse, or right. You are going to work today in your book on your problem set. Problem number 1, you're going to be classifying each triangle by its side lengths and angle measurements, and you're going to circle its correct names. Now, I want you to look really closely right here. Do you see how the people who made Eureka Math have drawn those little dashes in? Well, guys, they are helping you out. They are letting you see if there are dashes, that is showing you the sides that are equal. I'd like you to make sure you have your right angle template handy, though, so that you're able to identify where a right angle is, but they've even drawn it in right here. All right, so you've got some questions to answer. I'm just going to say right now that I really want you to do problem number 1. I'd like you to try 2 and 3. And when you get over here, this one is going to be a little bit tricky, but I'd like for you to try it. It says to use a ruler to connect points to form 2 other triangles. And so here, you might just take a ruler And you might connect points. It says you can only use each point once, so you've made this one. And we have a triangle, and this triangle's name is going to be triangle ABC because he has points ABC. And then I'm going to decide what kind of triangle is triangle ABC. Let's look at his sides. Wow, none of these sides are equal, so he's a scalene. And let's look at the angles. If I need to, I can pull out my measuring tool. I think I'll just use this one right here from my lesson the other day. Oh, and I can see that this is definitely obtuse. So I'm going to put those marks in. These three sides are not the same, and I have one obtuse angle. So my triangle ABC is a scalene obtuse, and I want you to try to draw another one and classify it. And do your best to answer these questions. Now you have an exit ticket for today, and your exit ticket is on Canvas. So I'd like you to submit it if you have any questions. I want you to shoot them to me by email, and we can talk, whatever, if you have any questions about this. But I've had fun classifying triangles with you today by side and by angle. So see what you can do on this. Submit me your exit ticket on Canvas, and hope you have a great rest of your day today. Until next time.